Hello everyone, welcome back to chapter 8. So, one task is a demo, 10 tasks is a project. Today we give our app a brain, lists, text that behaves, and instant lookups. So first of all, we're going to talk about vectors. And as you can see here, I've created this vector called task. It's initialized to new. And we're going to take a look at what's happening behind the scenes. If you haven't already, your debugger is a programmer's best friend. And the way to get this debugger is essentially you click run and debug on VS Code. And it should ask you to install code LLDB. If you haven't already, I highly recommend you do. So once that's done, you do that, and then you click on the executable of whatever you named it. And boom, there you go. Just like that, we have the debugger. So as you can see, I've created multiple tasks here. And when I click this, I can see I don't have any tasks. My size is 0. When I push it, you can see that the vector is being populated. The difference between a vector and a static list is vectors are in the heap. They grow. And so it's perfect for our tasks. Now, if you were to essentially do the same thing using memallocate, you would have to free your memory once you've used it, while as in Rust, it's not the case. So anyways, this is why we're allowed to use vector, because it kind of does the memory management for you there. Moving on. Next, we're going to talk about safely accessing elements. So as you can see here, if you're confident about your element, what you can do is you can just do the and tasks 0, and you can see that we have our task. But let's say you're not confident about that. Well, we can do something called the safe lookup, where we essentially, just like we learned last time about the match statement, we can do an if let sum, and then we give it some broad name that we want to access from our vector. And if it happens, then it'll return all of this, else it won't do anything. That's what we call a safe lookup. Anyways, next let's talk about mutating through borrowing. So we want to borrow mutably to edit in place, because only one mutable borrow happens at a time. So that's why if you were to essentially do tasks.get, you would get an error screaming at you because it's not a mutable object. But if you were to do get mutable, then now this is considered mutable and you're allowed to change it. Moving on, we're going to talk about strings. So strings is a growable UTF-8 buffer. Length is in bytes, not characters. Slicing by index can be tricky sometimes. So as you can see right here, we have this mutable string that we've created called Namaste Rust. And if we do a push, you want to do a single quote. Single quote is considered characters. So we're doing a character push. And we can see this happening all in real time right here. S is equal to Namaste Rust. We push, boom, it adds it in. Now, if you wanted to add in a full string, then you would do push string, and then you can give it the whole string buffer. And just like that, we have hello. Same thing when it comes to interpolation, string interpolation. As you can see here, we're going to create a new title, call it edit video. And in our description, we're going to format that. So we're going to say the first object is going to be referenced with a closing and opening bracket, dash closing opening bracket. And then just like if you've done C, this is exactly how we do a printf. We then reference our objects, and that essentially gets stored in. Let's move on. So next, we're going to talk about hash maps. So as you can see up here, we have this mutable tag counts, and it's a hash map. So essentially, if you don't know what a hash map is, it takes some type of hash key. It can be anything. For instance, ours is a string type, and a value type can also be anything. This one is going to be a usize. And the way you initialize it is hashmap under : new, and you must have this use standard collections hashmap. So after that, we have this tags count. So what's happening here? We're going in through a for loop, we're going into a tasks, and for every t in tasks, we're cloning the tag, and we're checking to see if it's there or not. If the value has already been in the tag or not. So we do the first couple ones, and as you can see here, because we had Rust tagged 1, 2, 3 times, our key is going to be Rust, and our value is going to be the number of counts that you've seen it coming into tag counts. And that's hash maps for you. Next, let's talk about ownership. So ownership with hash maps. Essentially, when you push something into the hash map, you are essentially taking that value. So whenever you push a key and a value, you're essentially moving the key and value into the hash map. So it's not part of that object anymore. So the way we want to properly do that, if you want to keep the originals, is we borrow instead. So we can do a .clone, or we can do, if it's a string, we can do we can do one of these guys. We can do a .toString, something like that. And so now I think if I've done this right, I don't need that string interpolation anymore, and I should be able to. Okay, that's not what I wanted to do. Okay, I still can't do that, never mind. But the toString is the way to borrow instead. Yeah. All right, moving on. Let's actually do some upgrades to our task. And so we were actually in the demos folder. So let's go back to the chapter 8 folder here. We're going to add a couple of things here. We're going to reference, once again, the collections. So it was standard collections hash map. So we have that guy. Use double colon. Is that not double colon? Did I mess up somehow? Okay, I did mess up somehow. So we're going to create some new functions here. We're going to call this function add task. And so what this is going to take in is it's going to first take in our mutable vector of task. And it's going to take in our title, and it's going to be an and string, and then priority of u8, and then kind, and task type, and do, and option, and string. Boom. So essentially, you can think of the add task as just like the initialization, the init task that we had. So if we do mutable temporary here, and we do a task, new title, priority, kind, and do, you can see that we can now push it. Sorry, there we go. So now we can push it, and it will be added to the tasks. Same thing, let's add another one here. Call it list tasks. So we want tasks, tasks, and vector of task. Boom. And for t in tasks, print task t. So what that's going to do is that's going to print out all of our tasks, and we're going to do a count by tag ID, just like we saw in the demo example. We're going to create a hash map with our tag as our key and our count of how many times we use that tag as our value. So let's do that real quick. Nothing we haven't seen before. Clone that guy. Insert that guy. All right, so now we have all of our functions laid out. Let's update our main now. So this is our new, this was our previous main. So let's do this. We're going to create a new tasks here. We'll call it vector of task. And we're going to say vector new. So now we have a new task of vector. We're going to reuse some of our existing patterns here. So we're gonna say let mutable my task. So the task new video to task type video edit and none. Okay. Task type video edit none. So we're gonna get rid of that guy. And we're going to do a tag for it. We're gonna do a tag for it. We're gonna give it the tag of Rust. And we're gonna push it to our branch. Now, let's do the same thing, but now using our new function with our mutable task. We're going to prepare presentation. I'm going to give it a priority of 2, and we're going to give it the task type of research. And inside that, we're going to give it the research that we're doing. We're going to call it Rust lifetimes, and we're going to give it a due date of string from 2025 to 08/010. This is 17th. We'll do 17. All right, and that's how you add a task. I really don't like this, the fact that it's so far apart. So we're just gonna bring these a little bit closer, so that way I can kind of like see everything on the task. Get rid of these guys for now. Yeah, let's get rid of those guys. And then let's do a progress update via mutable borrow. And we're going to do if let sum t0 tasks.get mutable, because we want to do a mutable borrow of 0. And we're going to do t0.status, and we're going to give it a new status of in progress, and we're going to give it 30. Yep. And so now it's 30% in progress. And let's do a list tasks instead. And now we don't need any of those guys technically, so let's see what happens here. And boom, there we go. Now we have our new tasks are in a vector list. I've pushed them using the normal push method or using our new function called add_task, and then we're listing the tasks. Next, let's talk about edge cases and gotchas. So collections power up our abilities to show data in a list format, but with rules, vector reallocation invalidates raw pointers, string indexing is bitwise, HashMap iteration order is not guaranteed, and inserting own strings moves them. Right, that's what we learned. So now our app manages lists, handles text write, and answers questions fast. Next up, error handling and making failures friendly. Thank you for watching.